Now let's talk about graphing linear inequalities. When we graph these lines, you're going to have a boundary line where that inequality is, and at that line it'll either be dashed or solid depending on which sign you have. So if it's strictly less than or strictly greater than, it's a dashed line. It'll look something like this. If it's less than or equal to or greater than or equal to, it'll be a solid line. Then we're going to figure out where to shade the rest of our graph. When we're shading these, it depends on whether or not we are less than or equal to, greater than or equal to. If it's any sort of less than, we're going to shade below our line. So what that means is, say, if this is our line, we would shade every part of the graph that's underneath that line. If it's above, if it's greater than, then we'll shade everything above that line. So let's look at some examples so this makes more sense. We need to graph these and then determine an ordered pair that is a solution to that inequality. When we're graphing inequalities, we still need to make sure that it looks like slope-intercept form. So we're still needing to get y by itself. So in number 4, I'm going to start by subtracting 5x from both sides. So we have 2y is greater than negative 5x minus 8. Then we can divide everything by 2. Y is greater than negative 5 over 2x minus 4. Just like with graphing an equation, now we need to graph the y-intercept, which is this constant that's by itself. So we go down 4, 1, 2, 3, 4. And there is our y-intercept. Then we're going to plot some other points. Since this is negative, we can go down 5 and to the right 2, or up 5 and to the left 2. So I'm going to go up 1, 2, 3, 4, 5, and to the left 2. There's another point. Then we can do it again. 1, 2, 3, 4, 5, 1, 2. It goes off the graph a little bit, but there's another point. Now, since this is strictly greater than, it's not greater than or equal to, this means we'll have a dashed line through these points. Now we need to worry about the shading. Since y is greater than all of these values, that means it's increasing, so we need to shade to the right or above our line. In the next example, we have 4x minus y plus 2 is less than or equal to 0, so we're going to get y by itself. First I'm going to subtract the 4x and the 2, so we have negative y less than or equal to negative 4x minus 2. Then I'm going to divide everything by negative 1, and when I do that I'm going to switch my sign. So y is greater than or equal to 4x plus 2. My y-intercept is at 0, 2. My slope is 4, so I'm going up 4 and to the right 1, or down 4 and to the left 1. So let's go down 1, 2, 3, 4, and to the left 1. Down again, 1, 2, 3, oh, this is going off the graph, and to the left 1. Now this one is greater than or equal to, so here we're going to have a solid line through these points. And this one's also greater than or equal to, so that means our y values are increasing. So from that y-intercept we're going up, so this time this is where we're shading because it's above that line. Finally, number 6, we have x over 3 is greater than 3y over 4 plus 3. Goal is to get y by itself. So I'm going to start by subtracting 3 from both sides. So we have x over 3 minus 3 is greater than 3y over 4. Then I'm going to multiply everything by 4. So then 4/3 x minus 12 is greater than 3y, and then we'll divide everything by 3. That leaves us with 4 over 9x minus 4 is greater than y. If you prefer to have y on the left side, you could rewrite it, but make sure you keep the arrow pointing in the right direction. That would be y is less than 4 over 9x minus 4. Both of those mean the same thing. Now when we graph, I know that it's not going to fit on this graph as it is, so I'm just going to make my scale on this graph 2. So each little tick mark is 2 units instead of just 1. So our y-intercept is negative 4. So here's negative 4 when we have a scale of 2. And then our slope, we're going to go up 4 and to the right 9. But again, keeping in mind our scale here is 2. We're going up to 4 and to the right 2, 4, 6, 8, 9. Then we could also go to the left or down to 4 and to the left 2, 4, 6, 8, 9. This one is strictly less than, so we're going to put the dashed line. And it's less than, so this time we are shading below. Now, the rest of the directions say to determine an ordered pair that is a solution to the inequality. A solution to these inequalities is anything that is either in the shaded region or on a line if that line is solid. So we're going to pick some coordinate point that is either on a solid line or somewhere in the shaded region. If it's a dashed line, we can't pick any of the points that are on that line, but we can still pick anything in that shaded region. For example, 0, 0, or 5, 2, anything that's in this shaded region. I'm just going to go with 5, 2. Literally anything that's in the shaded region. If it's not shaded, if it's to the left or if it's below this line, it's not a solution. In number 5, we could pick anything in this shaded region or anything along this line because it's solid. We could pick 0, 2, or we could pick -3, 4. Any of those are fine. And then a solution for number 6, since it's dashed, it can't be anything along the line, but it can be something in the shaded region, such as 4, -4.